Okay, so ang topic natin ngayon is about fiber optics technology, and ito na yung magiging last discussion natin, and hanggang dito yung magiging coverage ng final exam. So to start, ito yung mga chapter objectives. First is to understand the basic operation of the fiber or optical fiber as a communication link, and then to recognize the advantages of the optical fiber compared to the standard copper wire. So to recognize also the difference between single modes and multi-modes fibers, as well as to define and understand the terms grid index, step index, and modal dispersion. So also to list and describe the various components incorporated into the fiber link, and to analyze an optical system loss and compute a system budget to meet the minimum power requirements. So during sa last part ng discussion, dun yung may mga computations tayo. Okay, so as an introduction, optical fiber cables are the newest and probably the most promising type of guided transmission medium. So, siguro familiar na naman kayo dito. Ngayon, halos lahat ng mga, or hindi naman lahat, but nag-start nang mapalitan yung mga dating metallic cable natin for communication application ng optical fiber cables dahil dun sa different or sa many advantages niya compared dun sa traditional cables. So, i-discuss natin mamaya ano yung mga disadvantages and as well as yung mga disadvantages. So, sa optical fiber, yung electromagnetic waves are guided through a media composed of a transparent material without using electrical current flow. So, pag nagpropagate tayo ng electromagnetic waves sa metallic cable, kuryente yung dumadaloy dun. But in optical fiber, hindi na involved or walang kuryente na dumadaloy. So kahit hawakan mo yung kable, hindi ka makukuryente. It uses light as the carrier of information. So ito yung pinagkaiba niya. Instead na kuryente yung magke-carry ng information. So dito, ang carrier ng information natin is light. And it uses frequency of 100 GHz to 400 GHz. So, ganyan kataas yung frequency range ng ginagamit natin for fiber optics technology. Kasi yan yung frequency range ng light or ng visible light. Okay, so why optical fibers? First, ito yung mga advantages niya compared sa traditional. So, yung una, lightweight and non-corrosiveness of the fiber make it very practical for aircraft and automotive applications. So, if ang gagamitan natin is, or yung paggagamitan mo nung fiber optics is sa mga vehicle or automotive, lalo sa aircraft, mas practical gamitin yung mas magaan. Which is, if i-compare mo yung weight ng fiber optics compared dun sa mga metallic cable, alam naman natin na mas magaan yun, which is mas magandang gamitin for this type of application. And at the same time, hindi siya kinakalawang. So a single fiber can handle as many voice channel as a 1,500 pair cable can. So yun yung comparison natin in terms of the voice channels. So isang fiber, pero yung equivalent niya dun sa traditional nating metallic cable is 1,500 pair cable. So, imagine nyo kung gaano kalaki yung advantage na yun. And then, yung in terms of the spacing ng repeaters. So, sa fiber optics kasi, mas maliit yung losses na nai-encounter nung signal na dumadaan sa kanya compared dun sa traditional metallic cable natin. So, alam naman natin, ang repeaters, nilalagay mo yan kapag yung signal is degraded na. So, in terms of the repeaters, typically, for fiber optics, ang repeaters is nilalagay natin 35 to 80 kilometers. While for metallic cable, it is placed from 1 to 1/2 or 500 meters lang. So, malaking advantage na din yan. And then fiber is immune to interference from lightning, crosstalk, and electromagnetic radiation. So, paano nangyari yun? So, basically, alam natin yung crosstalk. And yung crosstalk, nag-i-exist yan kapag may kuryente. Kasi kung may kuryente yung kable, meron sa palibot niya na magnetic field. And yun yung primary reason kung bakit nag-i-exist yung crosstalk. And alam natin, sa fiber optics, wala namang kuryente dumadaloy dyan. So, walang magnetic field sa palibot ng fiber cable. So, yung crosstalk is minimize natin or technically halos wala na. In terms of lightning and yung other electromagnetic radiation, same reason kasi wala nga kuryente doon. Which is naapektuhan lang naman yung signal natin dito sa kable kapag may kuryente na dumadaloy dahil doon sa lightning as well as other electromagnetic radiation. So, ganun din sa environmental immunity. So, mas resistant yung fiber optics natin sa changing weather conditions. And at the same time, they also operate in wider temperature range. So, kahit sobrang init, hindi ganun maapektuhan yung signal mo sa loob ng fiber optics compare dun sa mga traditional natin na ginagamit na cable dati. Aside from that, katulad sa binanggit ko kanina, non-corrosive sila. So, kahit matapunan mo ng corrosive liquids, hindi siya ganun agad makakalawangin. And then, safety and convenience. So, katulad na banggit ko kanina, walang kuryente na dumadaloy. So, hindi ka makukuryente if nahawakan mo siya hindi sinasadya. Ang problema lang dito siguro if yung sobrang liwanag ng ilaw tumapat sa mata mo, so possible na mabulag ka, which is di mo naman siguro yung gagawin. And then in terms of convenience, mas madali mas madali siyang dalhin dahil kasi nga mas magaan. And then at the same time, mas madali install. And then economics. So if imagine mo na sobrang dami nung kaya mong ilagay na information, kahit medyo mahal yung ibang gamit dito, pag nakuha mo yung net profit mo, mas malaki pa rin siya compared dun sa dating kapag gagamitin mo yung dating cable. And then yung security. So, yung data mo is mas secured pag pinadaan mo sa fiber optics. Kasi, hindi ka naman basta dyan magtatap. Unlike dun sa mga normal nating communications cable, kaya mo nang makakuha ng information na dumadaloy dun sa metallic cable if not basta nag-tap ka lang ng another cable. So dito, hindi siya ganun kadali. Kailangan mo ng specialized equipments and tools. So kung may advantages, meron din tayong disadvantages. Yung una, yan, medyo mahal yung interfacing cost. So pag sinabi natin interfacing cost, ito yung mga electronic components or devices na kinoconnect mo dun sa kable. Kasi hindi lang naman basta may cable ka, pwede ka na magpalagay ng information. So, kailangan meron kang ikabit dun sa start and end or sa bawat sa terminal stations. So, yun medyo mahal. And then, yung tensile strength niya, mas madali siyang maputol or mabali kasi mababa yung tensile strength compared dun sa mga metallic cable. So, ang ginagawa para ma-improve yung tensile strength, binabalutan siya ng coating, additional coating, or jacket ang tawag of PVC. So, para maging mas matibay kahit i-bend mo. Kasi yung cable mo naman, yung dinadaan ng signal, yun nasa pinakagitna. So, if may mga outer layer ka, dagdag protection yun, pampalakas ng tensile strength ng cable. So, optical fibers are also more susceptible to losses by bending the cable. So, ito yung medyo mas mabigat na disadvantage niya kasi nga konting pagka-bend lang or pagkakilo ng cable, malaki na yung epekto dun sa signal sa loob. Okay, so mamaya di-discuss na kung bakit siya nagkaroon ng malaking effect compared dun sa traditional cable natin or sa mga metallic cable na kahit i-bend mo, tuloy-tuloy pa rin naman yung daloy ng kuryente dun. Okay, so yun yung mga disadvantages natin. So yung isa pa pala, is yan, specialized tools, equipment, and training. So, hindi ka lang kasi, halimbawa, magko-connect ka ng dalawang fiber optics. Hindi mo lang yan basta itatali and then connect. So, meron kang certain method or proper technique na kailangan gamitin para mas mapagkabit mo yung dalawang yan. And hindi lang yan basta mga normal equipments yung gagamitin mo na pamputol or pangkabit. So, meron yan para lang talaga sa fiber optics. Okay, so since light yung dadaan dun sa loob ng cable, kailangan familiar din kayo dun sa different properties ng light. Which is the same lang naman din sa mga properties ng radio wave. Kasi sa radio wave, it also exhibits light properties. So parang kahit i-review nyo na lang yan. Reflection, refraction, diffraction, absorption, scattering, and dispersion. So yan yung mga different light properties associated with the light inside the fiber cable or fiber optic cable. So if tinanong sa inyo ano yung energy ng light, so basically pwede nating isolve yung energy in a photon. And yung photon, ito is a particle of light kasi light is composed of many photons. So to solve for the energy of a photon, we can use this formula. E is equal to H times F, wherein yung E, yun yung energy. And then yung H, ito yung constant natin sa calculator, which is called Planck's constant, na may value na 6.63 times 10 to the negative 34 joule second. Okay, and then yung F natin will be the frequency in hertz. Okay, so simple naman yung formula. Product lang ng Planck constant and the frequency in hertz. So, unit na magiging energy will be joules. Okay, so proceed tayo ngayon dun sa construction ng optical fiber. So, basically, meron lang tatlong parts ang isang optical fiber cable. So, yung nasa pinakagitna, ang tawag natin dun is core. So, sa core, dun mismo dumadaan yung light na merong laman na information. So, after core, meron kang another layer which is called the cladding. So, basically, bumabalot siya sa core. And then, ang purpose niya is i-maintain na nandun lang sa loob ni core at cladding yung light. And then, yung buffer coating is for protection or pag-add ng tensile strength dun sa cable. So, yung three basic parts, the core, which is basically a thin glass center or minsan plastic, gawa din sa plastic, and dun dumadaan yung light. And then yung cladding is a outer optical material surrounding the core that reflects the light back into the core. So basically itong term na reflects, hindi talaga siya tama eh. Kasi ang nangyayari dun sa loob is refraction, hindi reflection. Refraction talaga yung nangyayari dun. Nagmumukha lang siyang reflection. Kasi magkaiba ng refractive index yung core and cladding natin. So, mas mataas yung refractive index ni core compared dun sa cladding, kaya nagkakaroon ka ng refraction, pero nagmumukha siyang reflection. Okay? So, and then yung buffer coating is basically a plastic coating that protects the fiber from damage and moisture. So, ngayon, there are three types of optical fibers na ginagamit sa industry. So, yung una, ito is depende kung saan mo siya ginawa, kung plastic or glass. Kasi it's either plastic or glass lang naman yung material na ginamit dyan. So, yung una is plastic core and cladding. So, ibig sabihin, yung core and cladding mo is made from plastic. Yung another type is glass, yung core, and then yung cladding is plastic. So, tawag natin doon PCS. PCS fiber. So, plastic core silica. So, yun yung meaning nun. So, meron kang plastic cladding and then yung core mo is glass. And then yung isa pa is glass core, parehas glass yung core and cladding. So, bakit may mga iba't iba pa tayong materials? Ba't hindi na lang glass, hindi na lang plastic? So, kasi may kanya-kanya silang karakteristik. Usually, pag plastic yung ginamit mo, mas mura yon compared dun sa glass. And mas madali siyang install kasi mas magaan. Alam naman natin, mas magaan ang plastic sa glass. So, yun yung isang advantage ng plastic. Mas mura, and at the same time, mas madali siyang install kasi nga mas magaan. Ang problema lang dito, yung plastic is nag-introduce siya ng mas mataas na attenuation compare sa glass. So, pag plastic, mas mataas yung attenuation compare kapag ang ginamit mo is glass, yung core or cladding. So, kaya kapag yung application natin is maliit lang yung distances, kalimitan ang ginagamit natin is plastic. Plastic material for short distances. Bakit? Kasi nga, kung short distance lang yan, so yung losses naman, kasi yung loss sa fiber, proportional yan sa haba ng kable. Kung maliit lang yung distance mo, halimbawa within the building lang, so maliit pa rin yung losses or yung attenuation ng light, ng signal. Pero if ang application or yung paggagamitan mo ng optical fiber is within the town or city to city or province to province, mas practical lang gamitin ngayon dyan yung glass. Kasi kung ang gagamitin mo pa rin plastic, since napakahaba na ng distance, mataas na yung attenuation. So if mataas yung attenuation, kailangan mo ng mga repeaters in between, which is mas magmamahal ka ngayon. Mas matataas yung cost. So mas practical lang gamitin kapag large distances yung pagitan ng mga station mo is glass yung material. Okay, so yun yung mga reasons natin. So for fiber characteristic, so the composition of the fiber determines the refractive index. Kung anong material yung ginamit mo, paano siya ginawa. So note that the refractive index of the core is slightly greater than the index of the cladding. So lagi yan. Laging mas malaki yung refractive index ng core compare sa cladding. Example, 1.48 and 1.46. So yung 1.48, ito yung refractive index ng core, 1.46 refractive index ng cladding. Okay, so yun yung standard natin. Laging mas malaki yung refractive index ng core compare sa cladding. Which in return, kung mas malaki yung refractive index, ibig sabihin, denser yung core compare sa cladding. Okay, so denser yung core compare sa cladding. Another characteristic ng fiber which depends on its size is its mode of operation. So pag sinabi nating mode, it refers to the mathematical and physical description of the propagation of energy through the medium. Or sa madaling salita, pag sinabi nating modes, ito yung ilan yung path na dadaanan. So, kasi meron lang tayong two classifications ng mode sa optical fiber. It's either single mode or multi-mode. Yung mode, ang tinutukoy niya lang, ilan yung pwedeng daanan ng light dun sa loob ng fiber cable mo. Kung single mode, ibig sabihin, katulad dito sa illustration natin, isang path lang yan. Okay, so yung light mo sa isang path lang dadaan. While for multi-mode, itong nasa taas na figure, yung different light mo, kasi light naman, madaming kulay yan, mayroon siyang iba't ibang path na dadaanan. Okay, so multi-mode, basically yung mode mo refers to the path. How many path? Now, paano natin aalamin yung number of modes or number of paths na dadaanan ng light sa loob ng fiber? So, you can use this formula, which is yung N is the number of modes. So, number of modes or path. And then yung D is the core diameter And then yung lambda is the wavelength of the light. So, familiar naman tayo sa lambda. And then N1 will be the refractive index of core. And then yung N2, refractive index of cladding. Okay, so dito naman, di naman siguro kayo magkakabaliktad sa N1 and N2. Kasi kung nagkabaliktad yung N1 and N2 nyo, mag-i-imaginary yan eh. Okay, so lagi naman yung N1 mo, yung mas malaki, which is lagi yun is yung core. Okay, so makuha natin dyan is, dapat, whole number. Okay, so i-round nyo lang lagi yan. Okay, so in terms of the refractive index, so meron tayong tinatawag na index profile, which is nakarelate to sa ano yung characteristic ng refractive index ng core and cladding. So dalawa lang ulit yan, it's either a step index or graded index. Pag sinabi natin step index, yung core and cladding has a uniform refractive index. Kung halimbawa, ito yung core, ito yung cross-section ng core, ito yung cross-section ng cladding, yan, isang cable yan. Itong buong core na to, kahit saang point ka dyan, kahit saang point mo tingnan, isa lang yung value ng refractive index. Ibig sabihin, meron siyang uniform refractive index. Ganun din sa cladding. Kahit saang point mo tingnan dyan sa buong cladding, isa lang yung value ng refractive index. Pero pag ang pag-uusapan natin is graded index, yung refractive index hindi uniform. So habang lumalayo ka dun sa pinakagitna ng cable, yung refractive index bumababa. Okay, so bumababa. Ganun din sa cladding, sa core or sa cladding. So sa pinakagitna, kung ito yung fiber cable mo, sa pinakagitna mo makikita yung pinakamataas na refractive index. Habang lumalayo ka sa gitna, yung refractive index mo pababa ng pababa. Okay, so sa pinakagitna, nandun yung highest index. And then, palayo ka ng palayo sa gitna, palit ng palit yung refractive index. So, yun yung yung pinagkaiba ng step and graded index. So, pag i-classify na ngayon natin ang fiber, meron na ngayon yung tatlong classification. Gagamitin natin yung mode at index profile. So, yung una is yung tinatawag nating multi-mode step index fiber. So, basically, pinagsama mo yung multi-mode. So, ibig sabihin, madaming path and then step index, which is uniform yung refractive index ng core and cladding. So, itong type ng classification itong classification ng fiber, typically meron siyang core diameter na 100 to 970 micrometer. Yung another classification is multi-mode, ibig sabihin madami kang path and at the same time graded index. So, ibig sabihin, yung refractive index ng core, hindi siya constant, nagbabago. Okay, so this is just an improvement of the multi-step index fiber. Yung mga disadvantages nito, in-improve lang natin dito, kaya siya nabuo. A typical graded index fiber has a core diameter staging. So, ito tandaan nyo yung mga constant na yan. Okay, so kasi constant yan para sa ganun type classification. And then, yung single mode step index fiber naman natin, ito yung pinakasimple. And ito yung most widely used sa ngayon, sa wideband communication arena. Yung core diameter natin dito range from 5 micrometer to 10 micro. And then standard cladding yung 125 micrometer. So dito, single mode ka, so isang path lang yung dadaan. And at the same time, constant yung or uniform yung refractive index ng fiber cable. Now, ano ngayon itong numerical aperture and acceptance angle? So, ito is related to kung paano ka magpapasok ng light doon sa cable. So, halimbawa, itong fiber cable natin, para magpasok ka ng light, meron kang certain angle lang na pwedeng yung light, yung angle of entrance ng light, meron ka lang maximum value yan. And pwede nating makuha yan using this formula. So, ang tawag natin dun sa theta C, yun yung acceptance angle, which is the maximum angle in which external light rays may strike the air fiber interface and still propagate down the fiber with less than 10 decibels loss. So, ibig sabihin, ito yung angle na yung light mo makakapasok dun sa kable. Pag lumampas ka dyan, yung light mo hindi na makakapasok. Or, pwedeng may makapasok pero konti na lang. So, yung tawag natin dun, acceptance angle. So, while yung NA dito sa formula, ito yung tinatawag natin numerical aperture. Which is basically, isa lang siyang numerical value or figure of merit na ginagamit para ma-present numerically yung kung gaano kalaki yung acceptance angle. So, ibig sabihin, greater yung magnitude, pag mas malaki yung value ng NA, greater NA, it means greater light ang pwedeng i-accept. Kasi kung mas malaki yung NA, ibig sabihin malaki din yung natin acceptance angle, which mas malaki yung light na pwede niyang i-accept, mas malawak. So, yun yung dalawang formula natin. Ang theta C is arc sine ng square root n1 squared minus n2 squared. And then yung NA is basically sine lang ng n1 squared or n2 squared or equal lang dito. Okay, so ano ba yung mga fiber losses? So yung una, yung light scattering or Rayleigh scattering. This is caused by the imperfection in the fiber or the microscopic irregularities in the fiber. So basically, light scattering, yung pagkalat ng light dahil dun sa microscopic na irregularities. Kasi dapat ito nangyayari yung microscopic irregularities during dun sa pagmamanufacture ng fiber. Okay, so yun yung isang loss natin, pagkalat ng light. And then, absorption ng light energy due to the heating of ion impurities result in a dimming of light at the end of the fiber. So, related din sa attenuation, basically absorption ng light energy. And then, radiation losses due to small bends. May mga instances kasi na pag may bend, nakakalabas yung light natin. Hindi na siya nagre-refract pabalik dun sa core. So, yun yung radiation losses due to small bends. And then, yung modal dispersion, which is, ito naman related to sa kapag yung index natin, kapag multi-mode. Kapag multi-mode kasi, madaming path, tama? Which is, ang nangyayari, pagdating doon sa pinakadulo ng fiber, hindi sila sabay-sabay dumadating, which is dapat sabay-sabay. So, yung hindi nila pagkakasabay-sabay, nagkukos yun ng losses. So, ang tawag na nga natin doon is modal dispersion. And then, coupling losses, ito kapag kakabit ka ng dalawang kable, or ikakabit mo yung cable sa another optical fiber device, halimbawa sa detector or sa light, may mga losses tayo na introduce dun. So, tawag natin coupling losses. Now, proceed tayo ngayon dun sa ano ba yung mga components na dapat present sa isang fiber optic communication system or fiber optic communication link. So, yung una, basically the source. So, yung source is syempre light. Kasi light yung dumadaan. So, ano ba yung mga sources natin ng light? So, sa electronics, mainly, ginagamit natin is LED or yung tinatawag nating ILD. So, yung mga other examples natin, pin photodiodes, LEDs, avalanche photodiodes, semiconductor lasers. Or, yung source natin is mostly ngayon, LED na lang or ILD. So, yung LED, yung mga typical natin light emitting diodes. And then yung ILD, yun yung mga lasers. So, meaning ng ILD is injection laser diodes. So, injection laser diodes. So, diodes pa rin. Okay, so yun yung dalawang typical source natin ng light. So, ito yung mga simple natin illustration or simple pictures ng mga source. So, ano ba yung pinagkaiba ng ILD and LED? So, yung una, yung ILD is coherent yung light na nilalabas niya. Pag sinabi natin coherent, hindi kalat or mas focus siya sa isang direction, which is mas maganda yon. Kasi kung mas focus, kung hindi kalat, ibig sabihin yung light power or light energy focus sa isang direction, diretso sa cable. And then, ang isa pa kagandahan ng ILD, pwede mo siyang gamitin sa higher bit rates. So, yun sa kagandahan compare sa LED. So, ito pinagko-compare natin yung ILD versus LED. And then, it generates a monochromatic light which reduces chromatic dispersion. So, monochromatic light. Which is reduce yung tinatawag nating chromatic dispersion or pagkakalat-kalat ng ilaw. Ang disadvantage ngayon ng ILD, una, 10 times na mas mahal. 10 times more expensive. Compare sa LED. And then at the same time, shorter lifetime. And yung last is temperature dependent. So pag sinabi natin temperature dependent, konting variation mo sa temperature na apektuhan na yung performance niya. So yun yung mga disadvantage naman ng ILD. Mas mahal, mas maliit yung lifetime, ibig sabihin mas madaling masira, and at the same time, temperature dependent. Konting changes mo sa temperature, affected agad yung performance. Pero yung kagandahan naman niya, higher bit rates, ibig sabihin mas mabilis yung transmission natin, coherent, hindi kalat, and monochromatic, which is mas nalilesen natin yung chromatic dispersion. So, after ng source, syempre kailangan meron ka ng link. So, basically, yung link, yan na yung fiber cable natin or fiber optic cable. Okay, so yun yung mga itsura niyan. And then, yung last component dito will be the light detectors. So, yung light detectors, typically, yan yung nakalagay sa receiving end natin. Yan yung detect nung light na dumaan din sa fiber link natin. So, usually, it is made of, or ito is composed of pin diodes and yung avalanche photodiodes natin or APD. Okay, so for the last part of our discussion, so meron tayo ditong simple illustration ng isang optical fiber system link. So meron kang signal source, meron kang optical transmitter which can be LED or ILD, and then yung optical fiber natin. So, optical receiver, which is, dito is avalanche photodiodes. So, pwede rin photodiodes lang. And then, yung signal destination. So, pag mag-a-analyze ka ng isang optical fiber system link, kailangan alamin mo ano yung lahat yung losses. And then, dapat alam mo din ano yung power na tinransmit mo. So, using this formula, malalaman natin ano yung marireceive natin ng PR dun sa receiving end. So, yung losses, na-encounter yan hindi lang dito sa optical sa channel. Yung losses, meron ka din sa simula hanggang dun sa pag-receive. Okay, so, then yung PT mo, yun yung galing dito sa part na to. Okay, so, typically, naka-dBm yan. Okay, so mag-example tayo ng mga problems. Una, calculate the numerical aperture and the maximum angle of acceptance for a fiber with core and cladding refraction indices of 1.55 and 1.51 respectively. Susulat mo natin yung given. Una, ang N1 is 1.55. Ang N2 is 1.53. So, ang hinahanap sa atin, ano yung NA, ano yung acceptance angle. So, NA is basically equal to the square root of N1 squared minus N2 squared. So, i-substitute lang natin, square root ng N1, 1.55 squared minus 1.53 squared. Ang NA will be, alam yan. So, based sa calculator, 0.25. So, ito na ngayon yung numerical aperture. Unitless yan. So, for the, balik tayo. So, for the acceptance angle, so ito pwede nating makuha as the arc sine of the theta, So, mali. So, ang theta C is arc sine of the NA. So, arc sine 0.25 equal yan sa 14.37 degrees. So, ito yung sagot natin. So, 0.25 and 14.37 degrees. Okay, so basic lang naman, madali lang. So, as long as alam mo yung formula. Okay, so another problem, calculate the energy of a 500 terahertz light signal. So, using the formula E equal to HF, yung H natin, yung Planck constant sa calcu, ilagay mo na lang. And then, 500, ilang tera? Times 10 to the 12 hertz. So, ang E will be equal to 52.73 times 10 to the negative 21 joules, or 52.73 zeptojoules. ZJ. Zepto. Negative 21. Okay, so basta energy joules unit natin. Okay, so last problem. Determine the optical power received in dBm. Capital lahat. So, small dapat yung letters yan. And watts for a 20 kilometer optical fiber link with the following parameters. Ang LED output power natin is 30 milliwatts. Okay, check natin to kung tama, 30 milliwatts. Pero double check natin kung megawatt. Kasi naka-capital. Okay, so yun is 30 milliwatts. And then meron ka daw 4 or 5 kilometer sections of optical fiber cable, each with loss of 0.5 dB per kilometer. And then may 3 cable-to-cable connectors na may loss na 2 decibels each. Light source to fiber interface loss na 1.9 dB. And fiber to light detector loss of 2.1 decibels. So halos lahat ng given naka-decibels except for the output power. So ang gawin na lang natin, since mas madami naka-decibels, convert na lang natin yung LED output power into dBm. Kasi yung kailangan sagot natin naka-dBm. Okay, so yung output power, ito yung PT dun sa formula. Yung PT is 30 milliwatts, which is also equal to 10 log 30 milliwatts over 1 milli over 1 milli. para makuha natin yung equivalent niya sa dBm. Okay, so equivalent to sa 14.8 dBm. Okay? Next, ano yung mga losses? Kasi ang formula natin para makuha yung power received is PT minus losses. So, kunin natin yung mga losses. Alam natin yung PT, 14.8 dBm. Ano yung unang loss? Yung una, meron kang ito, 5 kilometer section of optical cable each with loss of 0.5 dB per kilometer. Kailangan i-convert natin ito sa dB lang. So, i-multiply natin yan ng total length. Kasi meron kang 4 na 5 kilometers. So, ang total nun, 20 km. Kasi 4 times 5. So, 20 km times 0.5 dB per km equal lang sa 10 dB. Tama? So, 10 dB. So, minus 10 decibels. Next, ano yung kasunod na loss? Meron ka daw 3 cable-to-cable connectors na may loss of 2 decibels each. So, 3, tapos bawat isa, 2 dB. So, 2 dB minus 2 dB. Gusto mo times 3 mo na lang, minus 2 dB. So, papakita ko lang, 3. And then, meron kang light source to fiber interface loss na 1.9. And then, yung last, fiber to light detector loss na 2.1 dB. So, sagot. Ano yung sagot? Negative 5.2 dBm. Ito na yung power receive mo in dBm. So, para i-convert natin sa watts, yan, balik tayo. To convert sa watts, ang power receive is equal to 10 log yung power receive mo in watts divide mo ng 1 milliwatts. So, ito equals sa negative 5.2 dBm. So, shift solve mo, PR naka-watts over 1 milliwatt. Equal na lang yun sa 0.302 milliwatts. Okay, so yan yung sagot. So, other MCQs, ito ang mga objective type question. The cladding which surrounds the fiber core, A. Used to reduce optical interference, used to protect the fiber, acts to help guide the light in the core, ensures that the refractive index remains constant. So dito is acts to help guide the light in the core. Next, the 3 major groups in the optical system are components, data rate, response time, source, link, receiver, transmitter, cable, receiver, source, link, detector. So, letter D. So, tawag natin sa transmitting part sa source, then meron kang link, optical link, and then detector.